Alright, hello there class. We're going to get started on section 1.3, exploring real numbers. So our goal for the day is we are going to classify and compare real numbers. So the first part that we're going to be doing is we're going to classify types of numbers. So the types of numbers that we're going to talk about, we're going to talk about rational numbers, irrational numbers, integers, whole numbers, and natural numbers. So this is how we break it down. So you have real numbers is every number that you've worked with. We break it down into irrational numbers and rational numbers. Irrational numbers are numbers that do not repeat themselves, such as pi, such as the square root of a number. Their decimal point goes on forever and it never repeats itself. Rational number is any number that can be put as a fraction. So just as we get going, we'll speak more about it. But so rational numbers could be 4, could be 1/3, all right? Could be any number that you can put as a fraction would be a rational number. Anything you can't put as a fraction, anything that doesn't repeat itself, would be irrational. So this is what we're going to be looking at right here. So I want you guys to take note of it. All right, rational numbers, anything that's a fraction, irrational, it doesn't repeat itself. It's 4.13 and never repeats itself. It's not 4.13, 4.13, or 4.131313. That could be written as a fraction. So from there, we have integers, whole numbers, natural numbers. So I'm going to have it written over here so we can refer to it. So integers, just whole numbers. So it can't have a fraction. It can't have 1/2 in here. So it's whole numbers. So -3, -2, -1, 0, 1, 2. And it goes on to infinity in both directions. So any of that. Whole numbers just start at 0 and work themselves out. And then natural numbers start at 1 and work themselves out. So this is what we're going to be doing, is we're going to be classifying. So that's what it is. This previous slide here is just saying rational numbers, okay? Here's a big circle. Okay? All integers would be rational numbers. All whole numbers would be natural numbers, or would be rational numbers. All natural numbers would be rational. So it's kind of an umbrella. So we're going to go ahead and we're going to look at these and we're going to classify the different numbers that we have. So first of all, we look at 1/3. Does 1/3 fit into a natural number? No, it's a fraction. It's a fraction that's not a whole number. 0 wouldn't, so it's not here. So 1/3 would just be a rational number. 7. 7 would be a natural number. It'd be a whole number. It'd be an integer. And it would be a rational. So we'd write them all down. So if it's natural, that's going to be everything above it. 0, well, 0 is a whole number. It's an integer. And it's a rational. So we go with those. And then, not lastly, but -7 over 1,239. Again, that would be a fraction. So you go from there. One thing I'd point out to you guys, if I had, like, say, 4 halves, can you simplify 4 halves? 4 halves equals 2. So then we'd say, well, that's a natural, that's a whole, that's an integer, and it's rational. It can be written as a fraction, but it's also, when you simplify it, all of these as well. And our last one is pi. Okay, pi cannot be written as a fraction, so therefore it's irrational. Any type of square root, pi, that sort. So now we want to go and look at it. Are all whole numbers rational numbers? Okay, so are all of these, if I think about it, can all of these numbers fit in here? All right? And yes, that's true. All whole numbers are rational numbers. This statement here is true. The square of a number is always greater than a number. So if you take a number 2, if you square it, okay, that equals 4. So is this always the case? If I square a number, that'll always be greater than? Well, what about, let's take 1 squared. 1 squared is 1. Is 1 greater than that number? No. You could take 1/2 squared. Equals, this is 1/2 times 1/2. So 1 times 1 is 1. 2 times 2 is 4. Is 1/4 greater than 1/2? No. So it's not always the case that the square is 9. So you could say 1/2, 1/4, you could say 1. Any of those would be examples. Are all whole numbers integers? So are all of these included in here? And you can see, yep, 0, 1, 2, 3, so on to infinity. So that would be true. No fractions are whole numbers. So if I go to a whole number, is 1 a fraction? Well, I hope you understand that any number can be just rewritten as 1 over 1. So yes, any number that we have, it can be written as a fraction. We just don't to keep it simple. So that is false. You'd say 3 over 1, 4 over 1, any number, put it over 1. So now what we're going to do is we're going to compare numbers. Which one's bigger than the other? So if I look at which number is bigger, remember when you write greater than, the opening goes to the larger number. So 6 is greater than 5, so the opening points to the 6. 0.1 or 0.01, which one's bigger? Well, 0.1 is bigger, so you'd say 0.1 is greater than. Go to the next one, -4, -2. So now this one's 4 is bigger, but since it's negative, it's actually smaller. So -2 is greater than -4. And if you think about it, would you rather have -$2 or -4? Well, -2, all right, because it's a smaller amount. So the bigger the negative, the smaller the number is. Number here, 0.01 or 0.011. They both end at 1 here, but we have an extra. It's positive, so we'd say 0.011 is greater than. And then 1/3 or 1/4. Well, you could rewrite this as a decimal point if you know the decimal, or we need a common denominator. So 1/3 and 1/4. So the common denominator, we'd have to multiply. So I'd multiply this by 4, multiply this by 3. So 4 times 1 is 4, 4 times 3 is 12, 3 times 1 is 3, 3 times 4 is 12. So which is bigger, 4/12 or 3/12? Well, 4/12 is larger. 4 is bigger than 3, so it's here. Just a reminder that 4/12 was actually 1/3, so we'd say 1/3 is greater than 1/4. So then we move on. We want to write these from least to greatest. So once again, we have fractions. In order to get as we go through, we need a common denominator. So I'm just going to do number 15 as an example. So we have -3/8, -1/2, and then -5/12. We want the smallest number to the biggest, to the greatest. So just remember, anytime we work with negatives, the bigger the number, the smaller it is. All right, so we need a common denominator between all these numbers. So if we look at 8, 2, and 12, what's the smallest number that we have? Well, if you look at it, does 8 go into 12? I'd always look for that. It doesn't work there. All right, so I have 12, and then I'm just counting by 12, so then 12, then 24. Okay, so does 8 go into 24? So 24 divided by 8, yeah, that works. 24 divided by 2. So my common denominator is 24. So to make 8 go to 24, I multiply by 3, multiply by 12, multiply by 2. So 3 times 3 is 9 over 24. 12 times 1 is 12 over 24. Don't forget my negative. 2 times 5 is 10 over 24. Don't forget the negative. So we want the smallest number, so least to greatest. So we'd start out with this one here. This is the smallest number. Okay, that's my biggest number. So we'd have -12 24ths. Then we'd have -9 or -10 24ths. And then -9 24ths. Again, we're just going to look back. What was 12/24? That was -1/2. 10/24 was 5/12. And -9/24 was -3/8. And so that would be from least to greatest. All right? You can stop now, test yourself out, see if you can put this. Again, what would be our least common denominator of 4, 12, and 8? It would be 24. So you guys can go ahead and check that one out, see if you got it right. All right, find opposites. Opposite just means switch the sign. So the opposite of 3 is just switch the sign, -3. The opposite of -5 would be 5. The opposite of -0.2, switch the sign, so it would be 0.2. Okay, absolute value just makes your number positive. Absolute value just means the distance from 0. Distance can never be negative. You can't go -5 miles. So it's just saying how far away from 0 is this number. And you may have numbers on positive or negative, so it's always going to be positive. So if we look at it, I'm going to have two numbers just real quick. Here's 0. So this will go over our next two questions. What's the absolute value of 5? Well, how far away, so we want to know how far away is 5 from 0. And we can count 1, 2, 3, 4, 5 units. So it's 5. -5, again, 1, 2, 3, 4, 5. It's 5 units away. So we put 5 out there. So once again, absolute value is always positive. Last one's a little bit tricky. The absolute value of 5 is 5, and then you apply the negative. So since the negative is on the outside, that's why that would be negative. So we went over quite a bit. We went over rational fraction versus irrational, can't be written as a fraction. Then all the rational numbers can be classified as whole, as integers, whole, or natural. And then we went over and discussed organizing. Okay? So, we'll get going. Take your notes and bring them to class tomorrow. Thank you.